like sledding or not a big fan of the way we're skiing. Yeah, I like skiing too. I had been doing snowboarding. Now I'm think I'm going to transition into skiing. Um, but yeah, we try to make things fun up here in Minnesota, you know. We get all 4 seasons. You got to find something to do in each of them. Stay active. Oh, Buck Hill, yeah. I haven't been there in a while, but that's where I learned how to ski too. So, well, let's see here. Plan for today was just kind of review some stuff. Again, kind of like pre-calc kind of seems like, we're just doing these like random bits and pieces and then somehow everything all sort of ties together at the end. And so I get if it's a little bit confusing at times. That's kind of the way it is. But if we look at last week, okay, last week was a short week. I hope you enjoyed your fall break. There's just one lesson and assignment this week. Again, lesson 3 broke up into a couple parts. Lesson 4, and then after that, there is a quiz. So again, my plan was to kind of review lesson 3 and lesson 4 today. Just kind of look over some examples of things. And like I said, I kind of am having a little bit of difficulties with sharing my screen. So I'm going to have to look at the notes this way, which is totally fine. There's a unit circle. All right, lesson 2, lesson 3. So first thing, again, anytime we break up our unit circle, so maybe let's go back to here, okay? When I look at my circle, I could think about creating a triangle by going here, a right triangle, and over here. I can always create this sort of right triangle in my unit circle, which is why we take the time to review some of our right triangle trig. And again, these are sort of shortcuts. So this is like, all right, if I know that I have a 30, 60, 90, which again, we know happens a lot in our unit circle. We count by 30s oftentimes. 30. So this could be a 30, 60, 90. This could be a 30, 60, 90. This could be a 30, 60, 90. So we can get these 30, 60, 90 triangles throughout basically all of our circles. And we can do that with 45s. I can do 45, 45, 90. I can do 45, 45, 90. I can do 45, 45, 90. So creating these triangles within our unit circle can kind of create almost like shortcuts for us to solve. And so as a reminder of our shortcuts, and I don't know if I had you in geometry, but how I like to look at it is across from your 30-degree angle is your short leg. That's what we call X. Across from the 90-degree triangle is our long leg, or excuse me, our hypotenuse, which is like 2 short legs combined. So basically, whatever your short leg is, you multiply by 2 to get your hypotenuse, your long. And then across from the 60 is what we call the long leg. And to get your long leg, you take your short leg and you multiply by the square root of 3. So across from 30 is my short leg, across from 90 is my hypotenuse, it's multiplied by 2, and across from 60 is my long leg, which is my short leg multiplied by the square root of 3. 45, 45, 90 is even easier because we have 2 sides that are exactly the same. So across from 40 and across from 40 is exactly the same. And then across from 90 is my leg. So I just call these legs of my triangle. I multiply it by the square root of 2. So anytime you get either a multiple of 30-degree or you get a multiple of 45-degree, feel free to use these ideas to sort of use as a shortcut to figure out what is involved in it. And then we talked about some trig identities. Now, these are again important. I strongly recommend again, use your notes, okay? If you have these memorized, it might help you, but feel free to, create a cheat sheet, use these when you're going through stuff in case you can't remember. But Cosecant is sort of the reciprocal or opposite of sine. So if we put 1 divided by cosecant, that's actually going to equal sine. Cosine, 1 divided by secant is going to equal cosine. Cotangent, 1 divided by cotangent equals tangent. So understanding how, if I'm trying to sort of simplify equations, I could substitute in for sine 1 over cosecant. Why would that be helpful? Well, if I had a cosecant on the numerator and a cosecant on the denominator, 2 divided by 2 cancels out. 5 divided by 5 cancels out. Cosecant divided by cosecant cancels out. So I can sort of use these properties to rewrite it so that I can eliminate things and sort of solve them quicker. Same with these Pythagorean identities, okay? These are important, again, to use as substitution. If we know that secant squared is in our problem, we can sub in a 1 plus tangent squared. That may help us simplify. That may help us reduce our problem so that we don't have as many variables or as many things that we have to calculate. Now it's important to note, and it's written in green here, we can manipulate these. So what if I don't have equals 1, but I have equals cosine squared? Well, just subtract sine squared, or vice versa. I could subtract cosine squared and get sine squared theta equals 1 minus cosine squared. So whatever you need, you can use this to kind of figure out. Okay, if I know, hey, I got secant squared minus tangent squared, well, that's equal to 1, which is the same thing as 1 plus tangent squared. So understanding how to manipulate, these are how they're written, but we know more than just how it's written because we can manipulate it with algebra. Okay, let's see here. All right, so again, in this case, if I knew that sine theta was 0.6 and I was looking for cosine, again, I could plug in what I know and I could say, all right, 0.6 squared plus cosine squared theta equals 1. I'm going to say, all right, well, if I subtract this, I get 0.64, and then that's going to work out nice because we know that 64 is a perfect square, so I could get cosine of theta equal to 0.8. So again, using these properties to apply what we know to sort of solve problems. Here's an example I kind of alluded to earlier. Again, cosine theta, secant theta. I want to somehow get something so that I can cancel out. Well, I could rewrite cosine theta if I were to scroll up and look at my properties. We said that cosine theta, I think I went a little too far. Cosine theta is the same thing as 1 over secant theta. So all I had to do was rewrite, hey, 1 over secant theta times secant theta equals 1. So really, cosine of theta equals 1 because these are going to cancel out. And something like this where I end up getting multiple, okay? Secant squared, these cancel out. Secant squared minus tangent squared, that's one of my specific properties, okay? That was one of those that we had up here where I just recognize secant squared theta minus tangent squared theta equals 1. I can manipulate this to get a substitution. That's our goal, is to sub in something that we know. More examples of right triangle trig. Again, using opposite adjacents. Remember SOHCAHTOA, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. All right. And then when we don't get those nice 30, 60, 90 or those 45, 45, 90 triangles, sometimes we just got to use our relationships. So again, what I'm looking at is I'm saying, okay, I know sine is related to my y, cosine is related to my x, and it's all going to be how it is into what if we think about our unit circle, the hypotenuse of my triangle is really like the radius. So that's where this is coming. If I think about a circle going around here, the hypotenuse of my triangle is actually like the radius. So that's where we get these situations. And then again, notice the opposites. Cotangent is inverse of tangent. They're just flip-flopped. Secant is inverse of cosine. You switch the numerator and the denominator. And cosecant, you switch the numerator and denominator of sine. So if you can understand these three, you can understand these three. All right. I've got an example of this. Let's jump to that. So I've got an example of this. And again, there's a lot of ways to look at this stuff. This is basically what we were getting to is depending on what side you're going, this could be my angle, or again, I could go counterclockwise or I could go clockwise. It's going to determine whether my angle is positive or negative. So really, these are kind of like the same angles. It's just if I'm going over more than once, I do 360 plus 30, which gives me 390. So I'm really getting the same angle. And then recognizing where are our X's positive over here, where are our Y's positive up here. And then again, you can use that to help simplify by just understanding the positive and negatives of your quadrants. We just looked at something like that. Again, this is kind of can be like a cheat sheet for you. If you're wondering what are my positives or negatives, these are all 6 trig functions in each quadrant. You don't need to memorize this because you could always figure it out. You could say, well, I know what sine is, so if I flip it, I'll get cosecant. But it can be a shortcut for you. Finding the 6 values. And let's jump to the one that I wanted to go over. Not quite there. Right here. All right, so let's assume that cosine theta cosine theta is equal to negative 4/5. Well, let's find the exact values of sine theta and tangent theta. Okay. Well, if I know that cosine theta is negative 4/5, that means my x is negative 4 and my hypotenuse is 5. Now, we recognize this as being a perfect triangle or a Pythagorean triple where it's 3 squared plus 4 squared equals 5 squared. So again, I could use the Pythagorean theorem to figure this out. I know that this is 3 right here. However, I can get my cosine to be negative 4, my radius to be 5, and I could build the same triangle over here, but this time I have a negative 3. So I potentially have 2 different answers right here. By working this problem where my 3 is positive, or working this problem where my 3 is negative. All right, so again, if we try to figure this out, we're trying to find sine of theta. So sine is opposite over hypotenuse, which would be 3 and 5. And tangent is opposite over adjacent, which would be 3 and negative 4. So again, my sine of theta is opposite over hypotenuse, 3/5. My tangent is opposite over adjacent, which is 3, negative 4. Same thing over here, because again, I might have more than one answer. If I'm going from theta, okay, I'm going to say, all right, this time my sine is opposite over hypotenuse. This time this is a negative 3. My hypotenuse is still 5. And then when I do opposite over adjacent, I'm going to get negative 3 over negative 4, which really the negatives cancel out and give me positive 3/4. So just given, hey, cosine is equal to negative 4/5, I'm able to find sine theta and tangent theta, and there's actually two possibilities. Now, what if I gave you parameters and I said, well, your answer has to be between pi over 2 and pi? Well, that would be this quadrant. Or if I said your answer has to be between pi and 2 pi. Well, pi and 2 pi would be somewhere over here, but we know that this isn't a true answer. So this would be my only answer. So sometimes we'll ask you to limit, or we'll ask you to like specify to a certain angle or to a certain quadrant what the answer is. But for this example, we did, because it didn't do that, you had two answers. All right. A lot of stuff going on. Again, this stuff can seem tricky. I believe we're getting relatively close to finishing this unit up. So again, we've been working on it for a while. Your Class Connect assignment, again, to get credit, how do we earn points? Hopefully you followed along. Hopefully you understood something. I would review either your notes or go back and find that when we talked about the reciprocals of all of these again. So go ahead, match those up to find the reciprocals. Again, it's good to know if you have to check, but it's better to memorize. That way you can hopefully work a little bit faster. Simplify this this statement. Again, secant squared theta minus 1. If we look back on our notes, okay, we have a similar statement where, hey, if I do something with this 1, secant squared minus 1, that might equal tangent squared theta. Well, if I look back at this, I could say, all right, I could substitute this whole numerator for tangent squared theta. And then I'm just looking at, what is tangent squared theta divided by secant squared theta? I bet that's in our note. I say, all right, I know that secant squared minus 1 equals tangent squared theta. So I'm going to go ahead and substitute that in. I'm going to say, all right, this is the same thing as tangent squared theta over secant squared theta. And then I'm going to look at, again, what makes up those. So I see, all right, well, tangent I know is sine over cosine. Oops. So that's going to be on top. And again, this is technically my whole numerator, this whole scenario right here. And secant squared is 1 over cosine. So again, as I draw, I'll get a different color for my fraction bar. And then this is going to be in my denominator, 1 over cosine squared theta. And we know that when we divide fractions, we actually multiply by the reciprocal, which tells us to keep my numerator, my first term, the same. Here. Over cosine squared. I'm going to change division to multiply. And then I'm going to flip my numerator and my denominator of my second term, which leaves me, after everything cancels out, sine squared theta over 1, which means our answer is sine squared theta. All right, that's all I've got for you. Good luck. Fill that out, and I will see you next week.